Hello guys, welcome back to another video. In this video, we're still covering factoring, but this case we will do box method. Now, box method is essentially just grouping, but just in a systematic approach. Okay, so it's very nice, very organized. Um, I know I won't tell you which one I prefer, but I really like box method. Now, this works as well for quadratics, for cubics, for different polynomials later down the line. But first thing for box method, if I have this expression 2x squared plus 11x plus 5, and I just want to factor it, and it's just a reminder, standard form is ax squared plus bx plus c, and I'll go ahead and label it in this case just so you're aware. That means my a is 2, b is 11, and c is 5. When you start box method, always multiply your a times your c term. So my a term in this case is 2, and my c term is 5 in this case. Next step, find my multiples of 10. So two numbers that multiply to be 10. We got two pairs here, 1 and 10 and 2 and 5. So between these two pairs, I want to find one pair that when you multiply them, oh, my bad. Let me go back. If it'll let me go back. Oh, it won't let me go back. There it is. When you multiply them, you'll get 10. And then when you add them together, you'll get 11. So 1 plus 10 is 11, and 1 times 10 is 10. So that looks like that will work. If you check 2 and 5, 2 plus 5 is 7, which is not 11. This is saying here, 1 plus 10 is 11, and 1 times 10 is 10. Sorry about that edit, that was weird. But this is really where we're getting to the nitty-gritty of box method. So, as you can tell, box method involves a box. Who knew? So with box method, you're essentially just doing the opposite of the distributive property with kind of the distributing with box method. So we have 2x squared plus 11x plus 5. I'm going to place those terms inside the box. So the first term is going to be 2x squared. And then bear with me. I'm actually going to put the 5 in next. And if you want, you can put plus 5. But I'm not going to put 11x in there. Because in fact, I have two boxes left. So what I'm going to do is I'm going to plug in these two numbers. Because we're saying that 1 plus 10 is 11. And if this expression is 11, that means I can break this up as two separate terms. So I'm going to break up that 11x as an x plus 10x. So what that means for me is inside this box, I'm going to plug in a positive x and then a positive 10x. Again, I'll repeat that. What we did is we drew our box with 4 squares, and in the diagonal squares we put a 2x squared and a 5, and then these other two squares we split up this 11x, which is our b term, as two separate terms. And now from here we're just going to go ahead and take out our greatest common factor. We'll take it out of every row and every column. All right, so we'll start with the first row. So between the first row being 2x squared and x, I want to take out my greatest common factor. So my GCF there would just be an x. We can't take out any number because it's just 2 and 1. And they both have an x in common. And the most x's I can take out is just 1. Okay, let's try our second row. So between 10x and 5, I need a number that goes into both 10 and 5. Well, 1 goes into there, and so does 5. So the bigger the two numbers would be 5. And then ask yourself, can I also take out an x? In this case, I actually cannot take out an x solely because the 5 does not have an x attached with it. So that means here, for my rows, I'm taking out an x and taking out a 5. Okay, so let's do the columns now. Columns being, oh, my bad. Columns being up and down. So up and down. 2x squared We'll do this in a different color. We'll do purple. 2x squared and 10x. Let's take out a number that goes into both 2 and 10. Okay, so 1 goes in both 2 and 10, and 2 goes in both 2 and 10. So I can take out a 2 here. Can I also take out any x's? Looks like I actually can because they both have x's in common. So I'll take out 2x, and that'll be it. So next part here, x and 5. Oh, between 1 and 5, 1 is the biggest number I can take out, and they both don't have x's. So here's where it might be confusing. I can actually take out a positive 1 because 1 will go into anything. So this will lead us to our answer. My bad. Again, still working. This leads us to our answer of 2x plus 1 and then x plus 5. Now I will prove this, but I won't do this proof every single time on this video just to save time. But if you're like, I don't believe you, well, I will tell you that I can prove myself. So 2x plus 1 times x plus 5. Ideally, when I multiply this out, I should get 2x squared plus 11x plus 5. If I don't, probably messed up somewhere. I'll probably delete this video and start over then. So here, let's multiply this by distributive property. You can do FOIL. You can even do another Punnett square to multiply it. Doesn't really matter. That's up to you. I will just do distributive property, which means you take every term and multiply it by the other terms. So 2x times x is 2x squared. 2x times 5 is just 10x. 1 times x is just x, and then 1 times 5 is just 5. And that now tells us that, hey, we can combine those middle two terms, and oh my goodness, look what we get, guys. We get 2x squared plus 11x plus 5, and hey, that is the same expression that we started with. So life is good, life is nice. We get our answer here. And let me erase that because that can be confusing. But that is essentially box method. Box method is really just grouping, but just in a nice organized fashion. That's all it is. So here, again, ax squared plus bx plus c. Let me go ahead and do my first part, which is a times c. You don't have to write this part down. You can if you want to. But a is 3, b is 10, and c is 8. So this tells me a times c is going to be 3 times 8, which is 24. And then from there, like, okay, that's 24, awesome. Well, two numbers that multiply would be 24. We got 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Wait, why are we doing this again? Because we want two numbers that when you multiply get you 24, but also when you add get you 10. And where am I getting 10 from? That is my b term. I don't know, I'm sure why I'm pointing. You can't see where I'm pointing. So look at all your pairs. We got here one pair that works, but I'm going to check them all just to be safe. 1 plus 24 is 25, or 23 respectively if you subtract, so that won't work. 2 and 12, that gets you 14, or 10, that won't work. 3 and 8 will get you 11, but that's not close enough. But what about 4 and 6? 4 and 6, if I was to add them together, get me 10. But if I was to multiply, gets me 24. Okay, why did I do this again? Well, I did that because I can now break up that 10x, and I can say 4x plus 6x. Again, I can now break up that 10x and say 4x plus 6x, and this leads me to start my box. That's not too bad. That's a pretty good box. Okay, so first term was 3x squared. Last term was an 8. Wait, we have a 10x. which diagonal does it go in? It doesn't, because we're breaking up that 10x as a 4x and a 6x. So it doesn't really matter which one goes in which. So I'll just say 4x right here, and I'll just say 6x right here. Doesn't matter. That's just up to you. Now we're finding our greatest common factor in every row and in every column. So we'll start with the rows just because. Let's start with our top row, 3x squared and 4x. Well, gotta take a number that goes into both 3 and 4. Ooh, yikes. Looks like there really isn't a number. If anything, it'll be just 1. Okay? Well, can I take out at least an x? I can. 3x squared and 4x. They both have an x in common. That means I can take out an x. Sweet, let's try the second row. 6x and 8. What number do they both have in common? They got 1. Goes into both 6 and 8. 2. And that's about it, isn't it? So we can take out a 2 here. And I'll put like plus 2. That is a bad 2. Let me move it over. Can I also take out any x's? I cannot, because the 8 does not have an x attached to it. So we're done with our rows. Let's go to our columns. So let's try this first column right here, 3x squared and 6x. Again, what number can I take out between 3 and 6? I can take out 3. Can I also take out a variable? I can. I can take out an x, 3x squared and 6x. Let's do the second column. Between 4x and 8, I can take out a 4, because 4 goes into both 4 and 8. But I cannot take out an x, because the 8 does not have an x attached to it, which leads me to my final answer. And I'll say this is 3x plus 4 times x plus 2. And then I'm going to box it up all nice and neat. If I wanted to, I could distribute these binomials, again, either by Punnett square, FOIL, or just distribution property altogether. And I will end up getting this same expression that I started with, the expression of 3x squared plus 10x plus 8. So if you're taking notes for this video, please make sure to try this one by yourself before continuing. It helps to pause the video. And again, you don't have to write out this A, B, and C thing, but I tend to see that it helps some students. Because when I say multiply A times C, you're like, what is that again? Well, your A times C is going to be 2 times 20. Again, first term and last term. Awesome. So first step with our box method is multiply A times C, which is 2 times 20, which is 40. Perfect. So two numbers that multiply to be 40. That's not too bad. 1 and 40, 2 and 20, 4 and 10, 5 and 8. And that's it. For some reason, I was hesitating. I was like thinking, is there more? But there isn't. Now, I'm looking for, that's bad. Two numbers when you multiply, it gets you 40. And when you add them, gets you 13. 13 is your B value. So within those 4 pairs, our pair that's going to help us out here is going to be 5 and 8. So that tells me that instead of saying 13x, I can now say 5x plus 8x, because 5x plus 8x is the same thing as 13x. Oh, my bad. Now, look at this perfect box. That's okay. So let's put in all of our individual terms within the box. So 2x squared and 20. And remember, we broke up the 13x as 2 separate terms. So go ahead and place those terms within our box. We're going to find the greatest common factor of every row and of every column. So we'll start with the top row just because. So 2x squared and 5x, well, the only number they both have in common is 1, but they both have an x in common, so I'll take out an x. Okay, 8x and 20, they don't have an x in common, but they do have a number in common. They're both even. In this case, you can also take out a number bigger than 2. You can take out 4. Um, okay, that's all I can take out there. Let's go to our columns now. So our first column being 2x squared and 8x, they both can take out a 2. And actually, I'll do it in a different color. They both can take out a 2, and they both have an x with them. So I can take out a 2x here. And then my second column, 5x and 20, they're both multiples of 5. And that's actually it because the 20 does not have an x associated with it. So this leads me to say that if I multiply these two binomials, that would get my original expression. Therefore, I factored my expression of 2x plus 5 and x plus 4. Box method, again, is the same as grouping. It's just more organized. That's all it is. Final example, again, if you're trying this by yourself, if you're taking notes on this, please make sure to try this by yourself by pausing the video. But first step is always to multiply a times c. So a times c in this case is just 5 times 12. Now, we should have 6 pairs for 60 here. So we'll have 1 and 60, 2 and 30, 3 and 10, 4 and 15, 5 and 12, and 6 and 10. Oh, that's nice. 1, 2, 3, 4, 5, 6. What are we looking for again? We're just doing this aimlessly, aren't we? No, we're not, because we're looking for 2 numbers that when you multiply get you 60, but when you add them get you 23. So you can go ahead and check all those pairs and trying to find the pair that will work for you. In this case, we got ourselves, my bad, no, that's right. Okay, we have 1 and 60, 2 and 30, 3 and 10, 4 and 15, 5 and 12, and 6 and 10. For some reason, I'm not sure why I put 10 there. I was wondering why that didn't work. Okay, there we go. I was wondering why that wasn't working. 3 and 20, that works for us in this case. So 3 plus 20 is 23, and 3 times 20 is 60. So with this here, the reason why we did that is because we can now break up that 23x as a 3x plus a 20x. And that comes in handy because when we do our box, wow, that's not a good box. We're going to write all the individual terms within this box. So the first term is 5x squared. Last term is 12, and do not put the 23 in there because we are breaking up the 23 as a 3x and as a 20x. So with this here, again, break it up as 2 separate terms. We'll find the greatest common factor of all the rows and then the greatest common factor of all the columns. So between 5x squared and 3x, we can take out an x, and that's all we can take out. And then between 20x and 12, ooh, those are good numbers, we can take out a 4. That's correct. We can take out a 4. 4 goes into 20 because 20 divided by 4 is 5, and 4 goes into 12 by 3. And let me get a different color here. Perfect. So 5x squared and 20x. We're moving on to our columns. So the first column being 5x squared and 20x. They both have a 5 in common. Oh, and they both have x's. So I take out an x. And then our last one, 3x and 12. Well, they both have a 3 in common. And that's about it. I can't take out any x's. Which lead me to say that 5x plus 3 and x plus 4 would be our factored version. Again, biggest thing here is box method is just like grouping. We break up that B term as two separate terms, and we get those terms from these pairs here. So we pick two pairs that when you add them get you 23, and when you multiply get you 60. This was one of three methods. If you feel like you're not going to learn best with this method, there are two other methods you can watch on this channel as well. If you have any questions, please let me know. If not, have a great rest of your day. See ya.